Hi, my name is Paweł Maciejewski, and I'm a web developer at Allegro Group. And I am here to talk about indexed database. It will be a short introduction to this mechanism. So, agenda. First of all, I'm going to tell you why you should even care about indexed database. Then I'm going to tell you about its structure, transactions, database creation, basic indexed database pattern, and at last, I'm going to tell you about additional features of indexed database. Oh, snap. So yeah, why indexed database? And it's a really good question because since always, there has been a need for storing data locally on a client's machine. And we have cookies, yeah, but they are not the right tool for this job because cookies are sent to server and they are sent back, and all what they just do, they are cluttering your connection, yeah, and they are at most 4 kilobytes, so they're really not a mechanism for storing data locally, and people knew that, and people came with some solutions, some quick solutions like user data from Internet Explorer, or a local shared object from its, I guess, Flash plugin feature, or Dojo Storage X. It's a cool name for such lousy mechanism, but they are all wrong, they are all bad, and now in HTML5 era, we don't have to worry about it because we have two different technologies for storing data locally. Sprytny. You've been a very bad boy. So we've got two different mechanisms, and I'm talking about web storage with local storage and session storage, and indexed database, of course. And local storage, I must say, I love this mechanism. We make heavy use of it in Allegro Group. And it's brilliant because it's synchronous and it has very simple API with, I don't know, set item, get item, remove item, and so on and so on. So yeah, it's brilliant, but it's sometimes just too simple. And when local storage is just not enough, you have to use a local indexed database. And it's cool because it's something like local storage only on steroids. It's more structurized local storage, and it has slightly more complicated API. But this is the first answer for my question. But the second answer is more personal because I believe that playing with any kind of asynchronous API simply makes you a better programmer. So yeah, it's good for your programming skills, and indexed database has certainly an asynchronous API. So now maybe we should see how indexed database is structurized. As I have already said, indexed database enables you slightly more advanced key value management system. So like many other mechanisms in HTML5, I would say, like many other HTML5 technologies, you're always bound to your origin, where origin is a tuple made of your protocol domain and a port of your site. So within your origin, within your site's origin, you can have multiple databases, and each of these databases must be identified by a unique name, and each database has its own version. And within one database, you can have multiple object stores, and each of these object store is identified by a unique name, and that's all. Basically, there's nothing to say more about indexed database structure. But you should know that there are no many ideas known from relational databases here. So there is no such thing as schema here, which means that you can store objects in an object store, and those objects can differ one another in their structure. And there is no such thing as tables, as relations between tables, which means that you always have to worry about, you always have to take care about mappings between object stores. But yeah, it's cool. It's just another, like I said, it's a local storage on steroids. But comparing to local storage, it has asynchronous API. And that makes a difference. Because every change which you would like to make into your object store must be performed within an asynchronous request, and every request is bound to some kind of transaction. So let's talk about transactions, and it's, I think, one of the most important concepts in indexed database. It means that every transaction consists of one or more requests, and every request is a slightest change in your database. Request can be an operation like set, or put an object into an object store, or get me an object from an object store. Those kinds of operations are requests, and every request is asynchronous. It can fail, or it can be a success. And every transaction can be committed or can be aborted. When a transaction can consist of many requests, so if one of your requests fails, then whole transaction fails. It's a default behavior. You can prevent it, but the default behavior is that when one of your requests fails, then the whole transaction fails. And it's all changes made by those requests are rolled back. But if all requests are succeeded, then changes made by those requests are visible to the other world, and the transaction is committed. And transactions are atomic changes in your database. And you should know that every transaction has a scope, and the scope is a list of an object store with which this transaction can interact. And every transaction has a mode. And there are three modes of transactions. First, read-write mode, read-only mode, and a version change mode. First two, I think their name speaks for themselves, but you should know that there can be only one transaction in read-write mode interacting with one specific object store, and there can be many transactions in read-only mode interacting with one object store. I think that it's quite obvious. But the version change transaction, it's a really bizarre mode, because as you cannot simply walk into a model, you cannot simply create a version change transaction manually. It's made implicitly by an implementation, and it's closely related to a versioning system of an indexed database, and it's closely related to a method in which you are creating new database. So let's see how we can create a new database. Like I've already said, every change in indexed database must be performed within a asynchronous request, and even opening of a database is a asynchronous request. So you can make a request calling indexdb.open. Indexdb should be present in your global window. So yeah, and what indexdb open produces, it returns a connection request. And every request in indexed database has two callbacks, called onSuccess and onError. But this particular request is a special kind of request, and it has one additional callback called onUpgradeNeeded. And this specific callback, it's called in two different scenarios. First, when you are trying to open a database which does not exist. And the second scenario is when you are trying to open a database in a version which is higher than the one on the client's computer, because every database has its own version, and you can demand version higher than the one on client's computer, then you certainly need an upgrade. And what's even more special about this callback is that within this callback, in this function, you already have a transaction. You don't have to create it manually. In most cases, you have to create a transaction manually. Then you can get an object store. I will get to it. But in this particular callback, you have implicitly created transaction. And guess what? It's in a version change mode. So it's the only place in space and time when you have this kind of transaction. And it's more special because version change transaction is the only mode in which you can create new object store or delete a new object store. So basically, that's the only way you can structurize your database. So I can get my connection because connection request was a request. And every request has on success, on error, and every request has a result. And in this case, result of a connection request is a connection, obviously. And I can get it by calling event.target.result. And event.target is my request. I have it already in my scope, but the rule of thumb is that I can get my request from event.target. It's the same reference as a connection connection request. So yeah, I can get my connection, and I can check if there is, I can get my object store names, and I can check if there is any workers object store, and if it exists, I can delete it. And if there is not, and if there is any employee subject store, I can create it. And you should notice that delete object store and create object store are synchronous methods. They are in minority of synchronous methods in this API. It's mainly because if you are in version change transaction, you don't want to lose your grasp. You don't want to go back to an event loop. It could be possibly harmful. So yeah, there are synchronous methods. And create an object store returns a new object store. And when you have an object store, you can do whatever you want with it. You can create new requests, and we are going to see that in the next slide. But one other thing worth mentioning is that create object store takes two arguments. First, it's object store name, but the second is object store options. In this particular case, the only option I supply is key path with a value email. This means that in this object store, in employees object store, I can store objects, and they must have an email field. And this email field must be unique, because implementation will treat email field as a unique key for this object. That's the basically key path. So that's the common scenario for creating, structurizing, and version change in indexed database. And now when you know how to create and structurize your data, now I'm going to show you basic indexed database pattern. So as in a previous slide, I must create a connection request, and let's assume that a connection request is a success. I can get my connection from event.target.result. And connection is most important reference in indexed database. You should keep it for later. You should keep it for future, because with your it's a handler for your database. So you should keep it, I don't know, in scope or whatever you want. And with this connection, I can create a new transaction. And now I have to do it manually because I don't have implicitly created transaction. And I create transactions in two modes. I can do it by calling connection.transaction. First argument is my transaction scope. It can be an array of strings with objects stores names. And it can be a string with comma-separated object store names. And the second argument is actually optional. The default mode of a transaction is read-only mode. But in this particular case, I want to put some objects into my object store, so I need to create read-write transaction. And with this transaction, I can actually get my object store. I can do it by calling object store and supplying object store name. And this object store must be within my transaction object scope. And yeah, with this object store, I can create new request. Finally, I can create a new request, and there are a number of methods in object store, like set, get, put, clear, count, I don't know, delete, I think. And I think I mentioned all of them. And all of those methods will return a request. And we know the rest of the story, because every request has on success, and every request has on error, and every request has a result. And that's all, folks, because that's the basic index database. You can put some data into your database. You can get some data from your database. And that's basically how user storage works. But there is something fishy about employees.get. You should notice that if I want to get an object from my object store, I have to supply a valid key for that object when I want to use get method. And it's not the most handy method. What if I must iterate through all objects in my object store with get methods? It would be a horror. So there is more. There is more features in indexed databases. Ooh. So we have additional features like cursors. Cursors are basically another kind of request with which I can iterate through all objects in my object store. And there are bounds. I can lay bounds on my cursor. So I can say that I can create a lower bound and a higher bound and say that I want to iterat from object which key starts from letter, I don't know, C. And I want to end my iteration on object which key starts with letter, I don't know, D. And I can open a cursor, and that's it. It's using cursors and bounds are the basic method for querying your object store. And they are indexes. Indexes are not the kind of index you know from relational database. It's a slightly different idea. But indexes allows you to get an object from an object store by other property than your key. So I can lay index on a I don't know, name property, which doesn't really need to be unique. And I can get an index and open a cursor on it. So I can iterate through other properties. It's not my favorite feature of index database, but there is certainly worth mentioning. And there are cross-Windows events. So I don't know how to explain this, but I'm going to show you how it works. I think I'm going to make it so I don't see what's going on because, whoa, Houston, we've got a problem. Ooh. Thank you. OK. That's the simplest possible application based on index database. To prove you that it's really index database, I can connect to my database. And I can delete my database and do it again. So there is some initial data in this database, in this object store called employees. There is only one record called with key fragface@gmail.com. And I can, of course, add new one like foo@bar.pl and foo-bar and I don't know, barist. And I can edit, of course, yeah. And if I get all, it will be something like this. So yeah, and if it's persistent, it should be persistent. So if I don't want to close my favorite browser, so I'm going to close it again. So I have to make new connection and get all, and yeah, we've got all 2 records. So believe me, it's index database, but I am going to show you cross-window events, which are basically handy in situations in which you have active connection to a database on one tab, and you are trying to connect to a database on the other tab, and there is something going wrong here, because now I'm connected to a database called IDB test in version 1, yeah? But, pam, param, pam, pam, ram, pa, pa, pam, ram, pa, pa, pam, localhost, give me my localhost. And if I'm going to connect with this database in the same version, there's nothing to be worried about because it's a valid connection. But what if I would like to connect to a database in a version higher? Basically, it's not a prohibited operation, but when there is a connection to a database on with a lower version on the other tab, that is a pending connection, and there are 2 callbacks on a board, and and on pending, which allows you to do something about it. So you can, I don't know, you can tell your user that you are stupid and you have to close the other tabs because you know it's index database, your user. And I can, in this tab, I can reconnect to my database in a new version, and that's basically cross-Windows events. They're not so cool as in local storage. There is not so cool feature as local storage event, but they are certainly there, so yeah. And 2 other things you should know: that it's really not ready for a production index database. It's not a feature you can use from this day. It's only implemented in Firefox 12 now. That's not true. That's not true because it's implemented in Firefox 4 and Chrome 12. Yeah, but they are in the specification changed, and it changed the way you can version your database. And only Firefox 12 is up to date to the specifications. So those samples, which I show you, they are not valid in your latest stable version of your favorite browser. So yeah, it's really not ready yet. And they are still prefixed. So there is no IDB index database. There is no IndexedDB. There is no IDB transaction and IDB key range. There is Moz IndexedDB. There is WebKit IndexedDB, and so on and so on. So yeah. But index database is a really cool mechanism, and I thank you for your attention. But before questions, I have a little announcement. So we are looking for skilled web developers. So if you are a JavaScript ninja, with superb CSS skills, maybe work in Allegro Group is it's something you should be interested in. So if you are interested in joining us, there's more info in the lobby in our stand. So yeah, that's all. So now I'm listening to your questions.
Okay. Do you use some kind of local storage in Allegro right now, or is this just your hobby?
Yeah, we use local storage in Allegro. I personally use local storage in cokupić.pl. Yeah, but we have feature called clipboard in Cokupić, and we had it in written in. It was always in JavaScript, but the storage was in PHP session. It was PHP session based with all those requests, AJAX requests, and it was not good. It was not efficient. So we rewrite it in local storage, and we use local storage. And we have no fallback for IE7. Yeah. I love this company.
Okay, more questions? There's one.
You showed us a mechanism called bounce, if I remember correctly. Is there a way to, because I assume that when you told I can select something, for example, from letter A to letter C, yeah? This means some kind of sorting mechanism implemented to do it. And
yeah.
Is there a possibility to define some kind of, I don't know, comparator, my own comparator?
Comparator, you have to do it on your own. You have to use cursor with bounds, and you have to do it on your own. There is no mechanism in index database for doing this kind of job. Sorry.
Okay, one more question, and there will be a break.
Okay. Local storage can be easily cleaned up with browser settings.
Yeah.
Is IndexedDB any less vulnerable?
Yeah. No.
Yeah, such a thing.
It's the same story here. So you've got the same user. You have the same storage space, like in local storage. You have, in most cases, 5 megabytes. And if user wish to clear his, I don't know, browser history and other stuff, you're lost, yeah?